Welcome to Study Loop.
This is problem 108 of chapter 7.4 of Vector Mechanics for Engineers, Statics, and Dynamics. So for this problem, there is a cable stretching from A to B, and we are tasked with finding H, and we're also tasked with finding the slope of the cable at A. So in this problem, the horizontal distance from A to B is 8 meters. From A to D in the vertical direction is 4.5 meters. And from D to E in the horizontal direction is 6 meters. And also there is a mass applied at E, and it is 150 kilograms. So to start off with this problem, we are going to determine the weight of the cable. So we were given the mass of the cable of 20 kilograms. So it's the mass of the cable times G, which is 20 times 9.81 for gravity. And this equals 196.2 newtons. So the first thing we're going to do is draw the free body diagram for the whole problem. We're going to apply the reaction forces at A. AY is in the positive y direction, and AX is in the negative x direction. And also the reaction forces at D. DY is in the positive y direction, and DX is in the negative x direction. So we're going to do the sum of moments around D and set that equal to 0. And this will be negative 150, which is the weight at E, times gravity, because we're going to get the force, times 6, because there is 6 meters in the horizontal direction between D and E. We're going to add AX times 4.5, because there's 4.5 meters in the vertical direction between A and E. Subtract the weight of the cable, W, times 4, because there's 4 meters in the horizontal direction between the middle of the cable and E. So simplifying this, it's negative 8,829 plus 4.5x. And I'm going to move the W times 4 over to the other side. So it's going to be positive 784.8. So I'm going to go ahead and solve for AX, which equals 2,136.4 newtons. Next, we're just going to draw the free body diagram of just the cable ACB. And we're also going to include the reaction forces of B this time. BY is in the positive y direction, and BX is in the positive x direction. We're going to do the sum of moments around B, set equal to 0. This is negative AY times 8, because there's 8 meters in the horizontal direction between A and B. And we're going to plus the weight of the cable times 4, because there's 4 meters in the horizontal direction between C and B. So this will be negative 8 AY equals negative 784.8. So AY equals 98.1 newtons. Now we're going to draw a free body diagram from A to C, which is where half the cable is. So we're going to do the sum of moments around C and set that equal to 0. It'll be AX times H, which is here, that distance, minus AY times 4, because there's 4 meters in the horizontal direction between A and C, plus W over 2 times 2. And that's because there's 2 meters in the horizontal direction between where the W over 2 is applied and C. So simplifying this is 2,136.4 times H minus 98.1 times 4 plus 196.2 over 2 times 2. That equals 0. So we're going to go ahead and solve for H. H equals 0.0918 meters, which is 98.1 millimeters. and that is the final answer for part A. And lastly, we can solve for the slope of the cable at A, and it's just the inverse tangent of AY over AX, and sub in the values that we solved earlier. And this equals 2.63. Make sure your calculator is in degrees. And this is the answer for B, the slope of the cable at A.